A very good morning to one and all. Today we are going to see about measuring angles and traversing in theodolite. In measuring angles, we are going to see about three methods: general method, repetition method, and reiteration method. And traversing is the second method. So, measurement of horizontal angles involve three methods: general, repetition, and reiteration. Measuring horizontal angles. This is a simple figure showing the horizontal angle AOB. In general method, we normally keep it the theodolite at any station point, and two ranging rods is being kept at the two station point that is kept on either sides. And if we focus the first station point from 0 to A, that is fixed and kept it as 0 0 from the 1 year. And by losing the clamp screw, we'll be moving on to the next station. Care should be taken that there should be no change in the reading on the 1 year scale of the horizontal disc. Only the clamp should be loosened and telescope should be turned. And once this position is fixed 0 0 to A, we can lose the upper tangent screw or upper clamp screw, so that the reading will change and turning the telescope towards the point B, and we directly measure it. So this is general method of measurement. Now we'll move on to repetition method. This method is used in very accurate method. In this method, the same angle is added several times mechanically, and the correct value is obtained by dividing the accumulated reading by number of repetitions. So here you could find the number of angles are measured, same angle is measured each and every time cumulatively. Next method is the reiteration method. This method is another precise and comparatively less tedious method of measuring horizontal angles. It is generally preferred when several angles are to be measured in particular station. This method consists of measuring several angles successively and finally closing at horizon at the starting point. If we start with 0 or O, we'll end up with the same point. The final reading of the vernier should be same as the initial reading. This is reiteration method. Next, measurement of vertical angles. A vertical angle is an angle between the inclined line of sight and the horizontal. It is an angle of elevation or depression according to the object as shown in the figure. In the first figure, vertical angle 0 AOB, angle AOB is equal to alpha plus beta. In the second figure also it is alpha plus beta, but it's horizontal line. And in the third figure also it is alpha plus beta. But the angle AOB differs. In case of the first case, it is angle AOB is alpha plus beta. In the second case, the angle of AOB is only alpha, and in the case of third case, the angle of AOB is only alpha. So that will differ differently. Next is the theodolite traversing. A traverse is a series of connected lines whose lengths and directions are measured in the field. The system of surveying in which the angles are measured with the help of theodolite is called theodolite surveying. This is done in two ways: by measuring included angles or by measuring deflection angles. So by measuring included angles, it is more accurate than fast needle. The method of included angles is the most commonly used method. In this method, the magnetic bearing of any one line is measured, and similarly the magnetic bearing of all the lines are measured each and everything, and the sum is added and checked. By deflection angles. In this method, it is suitable for open traverse and is mostly employed in survey of river, coastline, roads, railways, and canals. Here we measure the right deflection angle or left deflection angle based upon the deflection station point that we are going to measure. So these deflection angles will be used for calculating the angles that is made by the stations. Here we will be not directing and ending with the same point, but the traverse will be an open traverse where we will be moving so and so. Next, though we take measurements by these two methods, we need to think about the closing errors. This method of closing error, the method is more accurate than closing error, but the one thing we have to take care of the closing error is that it should be in check with the angle. So that has to be enabled. Here the error of closure will be a point of consideration. The distance in which the traverse fails to close is known as the closing error or the error of closure. How to compute the latitude and departure. Latitude is a line on an orthographic projection of north-south axis of a meridian. Departure is a line on the orthographic projection perpendicular to the meridian. This is what is reference. From the picture you can identify what is latitude, what is departure. where it is negative and where it is positive is also shown in the figure. Latitude is positive latitude towards north and it's negative towards south. Similarly, departure is towards east is positive and towards west is negative. Balancing a traverse. A traverse is balanced by applying corrections to latitude and departure. This is called balancing. In case of a closed traverse, algebraic latitudes and departure should be 0. This is the following are the two methods for adjusting: Bowditch rule, transit rule. In the Bowditch rule, this is also called as a compass rule. Correction of latitude is length of that line by perimeter of that line into total error in latitude. Similarly, for departure, length of that line, perimeter of that line in traverse into total error of departure. Transit rule is used to balance a traverse in which angular measurements are more precise than linear measurements. Here, correction latitude is latitude of that line divided by the arithmetic sum of all latitudes into total error of latitude. And in case of departure, correction of departure and error line is equal to departure of that line divided by the arithmetic sum of all departure into total error of departure. So this is how we measure angles and do a traverse and find the closing errors. Thank you all for attention. If you have any queries, kindly post the questions. Thank you one and all.